Hello, good day. Once again, you're welcome back. Now, in this virtual class, we're going to establish the formula for cos theta plus alpha using um, trigonometric ratio. From here, we have a triangle OQP as a right angle triangle with an acute angle theta, and the triangle ORQ where alpha is also an acute triangle, and the sum theta plus alpha, they are also acute in nature. So here we also have another triangle ORN, okay, and triangle ROQS. Okay, we shall be using this to establish it. You can get this more clearly in the previous video. Okay, now let's look at what formula connects cos. Now looking at the triangle RN, the triangle ORN, here theta plus alpha is the angle involved. Okay, it means that RON is the opposite, YON is the adjacent. So cos is adjacent over hypotenuse. So it means that cos theta plus alpha is equal to O, the line ON, divide the line OR. Then the line OP is the sum of the line ON and the line NP. So it means ON lies between OP. So for us to obtain the line OP, for us to obtain the line ON, we make ON here the subject of the formula, so that the line ON is equal to the line OP minus the line NP. But here, the line NP is also the line SQ. Okay. Now let's substitute in place of ON the line OP minus line NP, so that cos theta plus alpha is equal to the line OP minus line NP, divide the line OR. Then we can simplify this as the line OP divide the line OR. This is a fraction. Okay, this is the common denominator, so which is the LCM, minus the line NP over the line OR. But the line NP here is also SQ, so we replace NP with the line SQ, so that the cos theta plus alpha is equal to line OP divide line OR minus line SQ over line OR. Now we need to do some adjustment here. The line OP over OR can also be written as the line OP over line divide the line Q OQ times line OQ divide line OR. So that, for instance, if we are moving OQ, line OQ cancel line OQ, we also obtain the line OP. Similarly, the line SQ over OR can also be expressed as the line SQ over OQR times the line QR over the line OR. Now, this is because of the fact that we are considering these angles. Okay, this angle, acute angle theta, alpha, and theta here. Okay, now let's look at what ratios are involved. What connects the line OP and the line OQ? From triangle OPQ, we see that the line OP, the ratio the line OP over the line OQ is cos theta. So we are looking at here theta here. What connects it in terms of cos here? We are looking at OP and OQ. So this is the adjacent to this angle, and this is the hypotenuse. So that means this is cos theta. OP, the line OP over the line OQ is cos theta. And from the triangle And from the triangle ORQ, let's look at the triangle O, the triangle O ORQ. Okay, we are looking at this. We are looking at the acute angle alpha. Okay, so if this is alpha, this is the opposite. This is adjacent. So we're looking at the line that connects OQ over OR. Okay, let's look at it here. The line OQ over OR is cos alpha. That is this angle. It's cos alpha. Now let's look at what connects the line SQ and the line QR. Let's look at the line SQ here and what QR. That means we are looking at this angle here, angle theta. Here, this directly, this is the opposite. This is opposite SQ, opposite, and this is the hypotenuse, RQ. So here, this is sine theta. Okay, you can see that is what is sine theta. What connects SQ and QR is sine theta. Now, let's look at what connects QR and OR. What connects QR? This is Q and arrow and the what? OR. Okay, so here we are looking at this angle here, alpha, and this is facing this side arrow Q, which is the opposite, and here is arrow O is the hypotenuse. That means this is sine alpha. Okay, so what connect that one is sine what? A sine alpha. So Q arrow, the line Q arrow divide the line O arrow is sine alpha. Now, by a way of substitution, let's replace all these expressions with their respective trigonometric ratio. And this become cos theta cos alpha minus sine theta sine alpha. So the value of cos theta plus alpha is equal to cos theta cos alpha minus sine theta sine alpha. Now, in case of cos theta minus alpha, we can easily obtain this by replacing alpha by minus alpha. And this become cos theta minus alpha is equal to cos theta cos alpha. Here the sign we change here become plus sine theta sine alpha. This is the appropriate way of handling the cos theta plus alpha using trigonometric substitution. All right, so we have known the formula for cos theta plus alpha and cos theta minus cos alpha. Please, if you like this video, please help me share and also subscribe. Have a nice time. See you in my next virtual class.